Uh, before we can graph a polynomial, we have to know what? Alex.
What a polynomial is.
What a polynomial is. Oh, there it is. We're all done. I don't have to explain anything more to you, right?
Please explain.
You may want a little bit more explanation than that. All right, so a polynomial, basically, what this is saying is if we had a quadratic, what's a standard quadratic look like? F of x equals what? I'm not telling you guys, so you got to tell me.
X plus b.
Ax squared plus bx plus c. All right. So you notice that the x is going down by how much? 1. So if I had a polynomial to the third power, it would be ax to the third plus bx squared plus cx plus d. Everyone see where I'm getting that from? So what would a polynomial, I guess I shouldn't have called that one f. What would a polynomial to the fourth power look like?
ax to the fourth plus bx to the third plus cx second plus dx plus d.
Okay, everyone's. Give me a break here. Okay, stop it. No, don't look like you don't know what I'm talking about. Just stop it. Alex? All right, so does everyone understand where that's coming from? What's the problem? Why couldn't I do 1 to the 27th power this way?
That's a lot of letters.
That's a little too many letters, isn't it?
Yeah.
They only can do it up to the 26th power. So what they're telling us here is that a to the n is the first letter. Then the next one would be a to the n minus 1, then a to the n minus 2, and so on until we get down to a. So if I had if I did the 27th power, my first one would be a to the 27th. It's just another way of writing variables when you run out, you don't have enough letters. So a to the first is a different variable than a to the second is a different variable than a to the third. Everybody understand what I'm saying? Not to the third, a sub 1, a sub 2, a sub 3. You guys understand what I'm saying or not? No? All right. The problem runs in. I'll come back to this. The problem runs. I could do what we just did up to 26 letters, right? Because you have a polynomial with 28 letters. You could have one to the 28th power, but you couldn't have 28 letters, right? So I could start bringing in Greek letters and stuff like that, but that gets too serious. So what they're saying is we're going to write it like this. If I have a squared, so my f to the x, instead of writing a, we're going to call that a sub 3 x squared plus a sub 2 x plus a sub 1, where these are 3 different variables. Okay, this is my a, the regular a, this is still my b, and this is still my c. It's just that we don't have enough letters to do it, so we always have an infinite number of numbers, right? So these are 3 totally different variables. Yes. Yeah. This is like saying I got to the end of the alphabet and I said, okay, the next letter is A sub 1. And the next letter is B sub 1, whatever you want, all right? So that's what they're saying there. So if you look back to here, they're just saying whatever power I have, I'm going to need 27 letters in front, right? If there's 27. So this would be 27, this would be A sub 27. This would be whatever it is, A sub 26, and this would be to the 26th power. All the way down until the last one is A sub 0. So actually I wrote this one wrong. This should be A sub 2, A sub 1, A sub 0. You can start at 0 if you want. So the powers always match with the subs. Yeah.
Why do they have like a negative 1?
What they're saying is, how did I know what I would call the next one? I started at 2 and I subtracted 1, right? So you always subtracted 1 to go down. So let's do a bigger one. Let's say I had a 1 to the 5th power. So we'll call this t of x. Okay, it would be a sub 5 x sub 5 plus a sub 4 x to the 4th plus a sub 3 x to the 3rd plus a sub 2 x squared plus a sub 1 x plus a sub 0. Okay, all these stand for, this is just like saying it's a completely different letter. Like A and B are different letters, a sub 5 and a sub 4 are different letters. Okay? This is saying this is the 5th leading coefficient, this is the 4th leading coefficient, this is the 3rd leading coefficient, whatever number they really are. So if I knew the formula, now it's 5. Someone tell me on this formula, what is a sub 4? No x, it's a number. What is a sub 4? Negative 2. So this is a sub 4, it's negative 2. And it's supposed to be pluses, right? So it's going to be negative. So these leading coefficients are the a's. So all this is saying is a polynomial looks like that. You have a leading coefficient and a variable to a power. Another leading coefficient, a variable power till it's done. Okay. Now, I'm going to give you a little bit more to go on than just that on what a polynomial is. Okay, a polynomial it's in the form f of x or y equals, they're the same. And then you have over here you have one variable to only whole number powers. So the powers can't be what? Fractions or decimals or no, well, some of the integers
Negative numbers.
can't be negative numbers. So it's just positive whole numbers. 0, 1, 2, 3, 4. So now we're going to look at these and decide which ones are polynomials. Let's try Kelsey. Is this a polynomial?
No.
Yeah. Okay, I only have one variable, and all the powers are whole numbers. How about B? Is B a polynomial?
No.
Okay, so tell me, where is there only one? Is there more than one variable on this side? No.
No, I don't know. Yes, no.
What's the only variable? X, right?
Yeah.
And are the powers on the X whole numbers?
Yep.
Yep. So why did you think it wasn't a polynomial?
Because pi.
Because of pi. But pi is just a what?
I don't know.
What is pi? Tell me.
It's a bunch of numbers.
It's a number, right?
Yeah.
So if I would have had, that's in front of the x squared, 1/4 is a number, right? Pi is a number too. Okay. Okay. How about C? Is C a polynomial?
No.
Let's try Mitch.
No.
Why not, Mitch?
No, no.
Okay. Could you look at it and think for a second? What does this say, Mitch?
One variable, two only whole number powers.
Okay. Is this all one variable? X, X, X. Are all the powers whole numbers?
Yeah.
They are?
Yeah.
Try again.
No.
No, because -1 is not a whole number. That's a negative number. That's not a whole number. All right. What about this last one? Is this a polynomial? Alex, why not? You'd say it has to go up by 1, 2, 3? Because the a sub 0, this could be a 0 that's gone, right? So that's not y. Jordan?
There's x for the power.
Yeah, x powers. X have to be a whole number? Not necessarily, right? I could put 1/2 into x and get an answer out, right? But that would be the 1/2 power then, so it's not a whole number. Not necessarily a whole number. So these two are not polynomials, these two are. Have we done a lot of stuff with polynomials? Have you done a lot of stuff with polynomials, Kristen?
Yes.
Yes. Okay, are lines polynomials?
No. Yes.
Let's look. Okay, let's see. Oh, I don't want that open. Okay, give me equation on line.
Y equals 2x plus 3.
Is that a polynomial?
No.
Why not?
Because I don't know.
What do you have written down for definition of a polynomial?
One variable, two only whole powers.
How many variables are on this side?
One.
Are they only the one whole powers?
Yes.
Well, what's the power in this one?
One.
One, that's a whole number. Okay. So yeah, lines are polynomials, and we've done a lot of stuff with lines in the past. What else have we worked with this year that are polynomials?
Parabolas.
Yeah, quadratic equations are polynomials. If I add f of x equals 1/3 x squared minus 2x plus 7, polynomial.
Yes.
Yes, it's polynomial. Now, the problem Alex was having before, if I had g of x equals 1/3 x squared minus 7, he didn't want to call that a polynomial because I didn't go x to x1 to no x's. Is this still a polynomial?
Yes.
Yes. What is the leading coefficient on the x squared? What's the leading coefficient on the x squared term?
1/3.
Okay, what's the constant?
What's that mean?
The one without a variable.
7.
-7. What's the leading coefficient on the x term?
Ooh, that's tricky.
0.
0. Okay, so it's there, Alex. It's just 0. It's 1/3 x squared plus 0x minus 7. Well, we don't write that down, but it's still there. So it still follows this pattern.
So you should have like 2x to the 19 plus 3x to the 4.
Yep. Okay. Catch that? What do you say? Okay, why not? Okay. Would you say I stop talking to each other? You do realize you sit right in front of me, right? Yep. Okay. Just check. All right. So now, before we can